So we've talked about microplastics and nanoplastics, which are 1/1,000,000th of a millimeter. It's a lot of zeros before the decimal point. I have to figure that out. So, but a study came out last year that showed that bottled water can have nanoplastics in it. So we can consume these nanoplastics.
Yeah, actually, one of the topic that we are studying in our lab is about the contamination of the microplastic in the drinking water. Because they could come up in the drinking water, even tap water. There are several studies that show that they are in the tap water. So that's why when we are discussing about the contamination in the farmland, the concern is that one of the concern is that these plastic could be transported to our drinking water resources and then eventually come up in our tap water.
Right, because we either get our water from impoundments, which can be water can be drained in it from farms and what have you, or from subsurface. But again, the nanoplastics are moving through the soil, so they can get taken up that way, and then they wind up in the
groundwater.
Yes,
maybe?
Exactly. Yeah. And that winds up in our water system and in us. So some of us have well water, so we're shallow wells. Some of us are getting water from different sources. So it's not that difficult to imagine we are getting these nanoplastics into us.
Exactly.
And like you said earlier, they can have heavy metals.
Like they can absorb heavy metals if there is any heavy metal in the agricultural field.
Right.
Yeah.
So, when we use our arsenics and what have you in our pesticides, they could pick all that back up, couldn't they?
Yeah, and any organic contaminants, we are using herbicide, pesticides in the farm, they can accumulate those on their surface, and when they get transported to other environment, they can have those on thetheir surface as well.
Oh wow. So they're carriers, really, aren't they?
Exactly.
They're carriers of the environment that they're in.
Yep.
Yeah.
They're really an indication of that. And so do they have any compounds themselves that they might release into the environment?
They are added, when they processing the plastics, they are adding some additives, for example, plasticizer or other sort of, antioxidants.
Stabilizers.
Lots of, additives are added to them because they want to facilitate their processing. And when they disintegrate and degrade in the farm, they can leach those contaminants out into the environment.
Oh, wow.
Like two of the common there is bisphenol A and there is phthalate. These are more commonly used as additives in plastics to improve their properties or to make them last longer. And these phthalates and bisphenol A, they're really harmful for human being. Like they can mess up with your hormones and reproductive system. So that's
there are some regulations for that. So I'm not sure how is the regulation for addition of those to the plastics, but generally there are some additives that they can leach out.
But there were some plastics that got banned, additives, because of the human hormones that they were mimicking.
Some of these are banned.
But those are probably still out there. Those plastics could very well be out there still carrying those compounds. Wow. What else do we need to do there? We talked about alternatives.
Yeah, one thing that we can do is that if we are applying plastic mulch, we do our best to recover them from the soil. As much as possible, we take them out of the soil and send them to the recycling facility or even the landfill. But we need to make sure that we are taking those out of our soil. We use, if possible, we use the biodegradable plastic mulch, or even better if we use the organic, options. We use the straw or wood chip or something that is organic rather than adding some synthetic material to our.
Now, you all have developed a filter for this, though, haven't you?
Yes, actually, recently, we had a project that we completed. It was a filter to remove the microplastic from the tap water.
And were you finding a lot of microplastics in our tap water?
Yeah, actually, we can do it. Was just simulated experiment in the lab, but nowadays, one of my students is testing the tap water for plastic. We found some plastic is just a preliminary data, but because our water treatment plants generally designed to remove the conventional contaminant, not the micro or nanoplastic, and even through the distribution system. Because some of these water infrastructure, they are plastic themselves. So they can release some plastic into the water as well. So there are some sources that are contributing. Or even in our home, for example, in my home, we are using the PEX pipes. So so there are some sources that possibly could contaminate the tap water with plastic. But there are research to be done. There are lots of unknown in this area. So definitely some research should be conducted in this area to confirm it.
Oh, sure. Because plastics are used in everything. It's very difficult. Even like your boxes that you brought your samples in are plastic.
Yeah.
And so probably the future is going to be that we're better at recycling our plastics, using alternatives to plastics, and maybe making the plastics out of non-petroleum.
Exactly. Just bio-based. Yeah.
Yeah. So do you think our bio-based, would they have any of the contaminants too that we see in stickers and what have you? Or
so bio-based, the main thing is that we are not using the synthetic plastic, just regular plastic, that they are lasting for a long time in the environment. For bio-based, they are designed to degrade faster, so they are going to disintegrate in the environment. So we are not accumulating them for a long time
and break down into their basic products: carbon, hydrogen, oxygen. That's what we hope. Whereas our real petroleum plastics never really do they?
It will take a long time. Yeah.
Much longer than our lifespan.
Exactly.
My daughters and I were talking about looking in the past and blaming our ancestors for this or that. I told them that I think plastic is going to be what our generation gets judged on. How could we have done that? Not using renewables. I remember most drinks that you bought when I was growing up was in glass.
Yeah.
And glass, as we know, can be recycled very easily. And we thought it was great when we got plastic. It was lighter, and we could throw away. It was easier to use, but that came at a cost.
Yes. Yeah. Definitely.
And I think the biggest surprise is what the plastics can latch onto and contaminate us with that.
Yeah. And there's so many different types of plastics, so we are yet to know what their effects are on our body. We only know so much about it. Yeah,
there's limited research in the health consequences, negative health consequences of plastic. So definitely there are a lot to investigate in this area.
They call it more planetary health.
Yeah.
How our whole as a society.
Yeah.
Can any of our issues that we have with our own health, can that be traced back to some of the plastics that we have?
I guess they should conduct more research.
Yeah, that's something that's probably they need to look at then. Yeah. Oh wow! Anything else that we're concerned with that we should know about plastic?
So, if we get back to the agricultural field, some of the things plastic can do through the agricultural lands that farmers could be more concerned about is the long-lasting fertility issues. So, if plastic gets accumulated, since they're breaking down, firstly, they can block the pores, or because of the existence of plastic in the soil, it can alternate the soil structure. So,
I haven't even thought about that part yet. Yeah, yes.
So, eventually, because of the change in soil structure, the water holding capacity, the moisture content of the soil, that can get changed. And that can eventually affect the crop growth. And the more and more plastics farmers keep using on their lands, the more plastics get accumulated over time, and that can create a problem with the fertility issues. The longer there are
when
plastics
we have
in
that
there,
for many years,
the fertility might reduce. So the quality of crops they grow, the vegetables and fruits we get might not be as good as we used to get.
So does plastic have a charge to it, like a plus, a minus?
Negative, yeah.
So it's a negative charge.
Yeah.
So it can act a lot like a soil particle then, and but it's not.
No.
Oh wow! And like you said, plug in the particles up, the soil structure.
It can influence the water flow through the soil and water retention.
Plastic surfaces are mostly negative. We found
Which
that
can attract cations.
Yes, they can.
But cations like metals, heavy metals, they have positive charge, so they can attach to the negative charge. And there are other sort of interaction. And something about plastic is that when they are degrading in the environment, their surface charge could change, or for example, when they are in the, there are some moisture, there is a possibility that some microorganisms grow on the surface of the plastic. So their surface charge could vary when they are on the farm. So that could influence their interaction with other contaminants.
Right. And also this negative charge makes it where they repel and they can move through the soil a lot easier.
Yes.
Deeper and deeper into the soil, into the water, into the groundwater. That's why we start seeing some of those issues.
And when we were studying microplastics, one thing we found that as they age, the negative charge on their surface increase.
Oh, really?
Yeah, the aging was photodegradation. So when they expose to the solar radiation and they age, they become more negative. Yeah.
Which could compound that effect then.
So could be possibly there could be more electrostatic attraction. Positive charges are getting more attracted to their surfaces. So like heavy metals, cations.
Yeah, but there are other, other sorts of interactions as well. This is just electrostatic. There are other sorts of interaction as well that could influence their contaminant transport.
Oh, wow.
Yeah.
Yeah. So we can have some issues here then, can't we? I think this has been fantastic about bringing awareness to it and how it affects every part of our life, and some basic steps that we can do.
Yes.
That we can really, really do.
And there are definitely some places we can think about replacing plastic. You were talking about hay. So it's much convenient to cover them with plastic if you're using those hay or silage as a feed for your livestock. So I know that's convenient and farmers are opting in for probably a cost-effective option. But if you build a silo, that's more more expensive. But again, that's long-lasting.
Right.
So some things, there is a trade-off between opting in for a cost-effective option or spending more and going for a long-lasting, sustainable option. Mm-hmm. So
we're going to have to stop and think about this different ways. One of the things that first came to my mind is year-round. Missouri is great because we're in the bullseye that we can have year-round grazing where you don't feed as much hay. You don't feed as much hay. You don't have to have as much plastics and that sort of thing. So there is those type of options too. Just changing how we look at our food production.
Yes.
Yeah. All right. Well, thank you all so much. This has been very interesting. I think we've opened a lot of eyes. There's been some things that I hadn't really thought about. How plastics can move through the soil. How they can, since they're negative, they can attach to our cations. Not only the heavy metals, but maybe some of the ones that we want for our plant growth, like potassium, for example. That's really important. And how it keeps getting smaller and smaller and smaller and can wind up in our drinking water, in our food. And probably we don't know quite where it can wind up at yet, have we? Because we haven't looked there yet.
Yeah, exactly.
There's so much to study.
And you may not, but you might be a little afraid to look at it. So, all right. Well, thank you all so much. Good luck on your dissertation. Seems like you've done a great job so far, and you got a lot to do, and a very exciting subject. And Dr. Salehi, it's been fantastic to work with you and continue as we're working on this, that we can come up with some alternatives and maybe how to manage our plastics in our life. So,
Yeah, thanks for inviting us.
You're welcome. All right. Well, this is it for Tim's Take, and we'll talk to you next time.